Good morning, good afternoon, good evening, everyone. So, today we are going to start with a new topic, and the name of the topic is static force analysis. Static force analysis. And the name of the topic is static force analysis, right? Okay. In this static force analysis, in GATE or EAC exam, you will not get any question directly from it, or maybe there is a very less chance that you will get any question directly from it. But this is very important. The being reason is because there you will find many questions which are solved with the help of this concept, which is static force analysis, right? Without delaying, we should discuss the topic. Okay, in static force analysis, as the name suggests, analysis of the force of a body which is at a static position, right? It is simply analysis of a force in which the body is at a static condition, right? For example, not for example, the condition is, first of all, or the topic is static equilibrium. Static equilibrium. Now, what is static equilibrium? Static equilibrium is a condition. Equilibrium, as you all know, what is equilibrium? Equilibrium simply means a condition which is at low or minimum energy condition. Minimum energy, isn't it? Lowest or minimum energy condition. Static, any body. Now, what is static means? Any body which is at rest or is which is at rest or is moving with uniform velocity, isn't it? Now, what do you mean by static equilibrium? Static equilibrium is a condition in which there is any body which is at rest or is moving with the uniform velocity. Okay, now what does it means? Uniform velocity means that the acceleration of the body is zero. So from this, can we conclude that we are especially talking about force equals to zero, isn't it? If any body is moving with uniform velocity, if any body which is moving with uniform velocity or is at rest, so no doubt the force acting on that body is zero, or we can say that the net force acting on that body should be zero or is zero, isn't it? Say yes or no. Are you getting it? Okay, I'm again repeating it. What I'm trying to say, if any body which is at rest or is moving with uniform velocity, so we can conclude that the acceleration of the body is zero, and from this we can get that the force acting on the body is zero, or the net force acting on the body is zero, or the net force acting on the body is zero, isn't it? Right. Or we can also say that tau, that is torque, is also zero, isn't it? We can also say that torque is also zero, because torque, if there will be a torque, then the body will not be moving with uniform velocity, then there would be some acceleration, isn't it? So therefore any body to be at rest, any body to be in static equilibrium, therefore any body to be in static equilibrium, the following condition must be fulfilled. The following conditions must be fulfilled. Right? And then what are the conditions which should be fulfilled? The first is summation of F net should be zero, isn't it? The force acting on the body, the net force acting on the body should be zero. Second, the moment should be zero. should be 0, and the third summation of torque, again net, here the moment is also net, should be 0, isn't it? These three conditions has to be followed anyhow to keep any body under static equilibrium. If I have to keep any body under static equilibrium, then these three conditions must be fulfilled. Is it clear? Okay. Now we will discuss about equilibrium of different bodies. Now we will discuss about what equilibrium of different bodies. We will discuss about what equilibrium of different bodies, right? The first case which we are taking is equilibrium of two force members. Equilibrium of two force member, right? Of two force member. Okay, equilibrium of two force member. Okay, then for any body, okay, if there is any body and that body is under the action of two forces, for example there is any random body of any shape and size, okay, and this body is acted upon by two forces. Let's suppose any force is acting upon this direction and any force is acting upon this direction, right? So let's suppose FA, this is point A, let's suppose, and this is point, let's suppose B, okay, and this is what FB, okay, and this is, let's suppose, B. Clear? Okay. Now there are, okay, FA and FB. Okay, so this body is not going to be at rest. Why? See, neither FA is equals to FB, isn't it? Here this condition is not fulfilled. FA, the magnitude of FA is not equals to FB, so the net force is not 0. And moreover the second condition, see, if I'll try to find out the moment acting on this body, see, if I'll join them through any point like this and I'll take the center of this body, then no doubt, see, these two forces are trying to rotate the body, isn't it? These two forces are trying to rotate the body. So neither the B condition, summation of moment, is fulfilled. None of the condition is fulfilled, so the body is not under the equilibrium condition, right? Okay, then what could be the case? Then what else could be the case? See, again, here is my any body, okay, this is the force acting in this direction. Let's suppose this is my x-axis, let's suppose this is my x-axis, clear, and this is again FA, and now again this force is acting FB, and right now, and this is again the x-axis. For example, we are considering the both as a x-axis, no doubt, okay. So see, and let's suppose the given conditions are that the force, magnitude of the force FA and FB both are equal, okay, and FA equals to FA, magnitude of FA is equals to magnitude of FB, right? Okay, see, the net force acting on the body is 0. The first condition is fulfilled. Summation of F net is equals to 0. This condition is fulfilled. But see, if I'll take the torque, if I calculate the moment, if I'll take the center of this body and if I calculate the moment, see, this body, this force will try to rotate the body in this direction, isn't it? Again, the second condition, summation of moment is 0, is not fulfilled. This condition is not fulfilled, so still this body is not under static equilibrium, isn't it? Are you getting what I'm trying to say? What I'm trying to say is, if a body has to be under static equilibrium condition, then these three conditions has to be fulfilled anyhow. Okay, the first condition is that the magnitude of the forces FA is equals to FB should be fulfilled. Secondly, the net moment generating in the body has to be 0. The third, that net torque in the body which is generated has to be 0. Then what could be the case? I'm drawing it here only so that you can, okay, if I'll turn the page, a little bit of concentration always gets disturbed, right? Okay, let's suppose if there is any body, right? Okay, then what should be the condition? Just think over it. What should be the condition? The condition should be FA should act like this and FB should act like this. Both should act in the same line of action, isn't it? Isn't it? Are you getting what I'm trying to say? So from here, the FA, we already know that the magnitude of FA is equals to FB. So the first condition is fulfilled, that the summation of F naught is equals to 0. Isn't it? The summation of F naught is equals to 0. Okay. In this second condition, see, if I try to calculate the moment generated in the body, then summation of moment torque is 0 here. See, because both are in the same line of action of the forces. See, the torque generated, there will be no generation of the torque because there is no perpendicular distance. I don't know whether you guys know much about moment or not, but still you should be knowing that the torque is calculated by the help of perpendicular distance. And see, there is no perpendicular distance, so the moment generated in the body is 0, isn't it? The first, the second, and the third condition, all the third condition are net is equals to 0. All the three conditions are fulfilled. Hence, this body is now under equilibrium, and this body is now under what? Equilibrium. So what are the conditions? What are the conditions for any body which is under the action of two forces, that the magnitude of the both forces should be equal, and they should pass through a same line of action of force. Basically, this will bring us the result summation of F naught equals to 0, moment torque equals to 0, and moment of this summation of net torque is equals to 0, isn't it? So this is how the two force member, or the a body which is under action of two force, will be in equilibrium. Okay, so in the next video, or in the next lecture, we will discuss about the equilibrium of three force members. Stay tuned.